In this video, we are looking at the numerical approximation, and we want to begin with location of roots of equations as a first part, and this one has got two categories. The first one is analytical method. When we talk of analytical method, we shall see how functions change signs, that is sign change. Then graphical method. In our discussion, we want to begin with analytical approach. Analytical method. When we talk of analytical method, this is also called the sign search method. And if a function, say f(x) is continuous such that there exists two roots, x1 and x2, and f of x1 is less than 0, f of x2 greater than 0, this will imply that there is a root. In the interval x1 or x2, or there is a root between x1 and x2. We are saying that if x1 is less than 0, that means it is a negative. If x2 is greater than 0, that means it is a positive, and means there is sign change from negative to positive, and that approach is what we call analytical method. And therefore, it means that this x1 is less than x2, because if x1 is giving a positive, then x2 gives the negative, then x1 will be bigger. But since x1 is giving a negative and x2 is giving a positive, that means x1 is less than x2. And we want to look at examples, how we can use this method. We have example 1 that shows that the equation x cubed plus 3x minus 9 equal to y has a root between x equal to 1 and x equal to 2. Now, when you are faced with this question, then the solution will let y be equal to fx, such that fx becomes x cubed plus 3x minus 9. Then f of 1 will be 1 cubed plus 3 times 1 minus 9, and f of 1, use your calculator, it will give you negative 5. Then f of 2 is 2 cubed minus 3 times 2 minus 9, and when you use your calculator, f of 2 will automatically give you 5. And clearly, you will see that f of 1 is a negative, f of 2 is a positive. And you make a conclusion and say that since f of 1 gives a negative, that is a value less than 0, f of 2 gives a positive and is a value more than 0, then we must see that there must be a root between 1 and 2. So this would be your conclusion, and you can realize that there is a change of sign of the function. So this is one of the ways of giving conclusion, or you can say since f of 1 times f of 2 is less than 0, if you multiply f of 1 times f of 2 will give you a negative, and it means it is less than 0, that means the root still lies between 1 and 2. So we can have an example 2, which is done the same way, that show that the root of the equation lies in the interval. So similarly, you let your fx be equal to x e power x plus 5x minus 10. Full stop, don't include the 0. The 0 ignore, you stop at 10 and put a full stop. Then say f of 1 will be 1 e power 1 plus 5 times 1 minus 10. Use your calculators properly, and when you substitute that in your calculator, it gives negative 2.28172. Now, f of 2 should be 2e squared plus 5 times 2 minus 10. Similarly, when you put 2 in your calculator, it gives 14.7781. And you realize that f of 1 gives a negative value of f of the function, f of 2 gives a positive, and you conclude and say that since f of 1 is a negative, so it is less than 0, f of 2 is a positive, so it is greater than 0, then the root lies between 1 and 2. So you can see it is similar to example 1, and that's how you handle that one. Similarly, we have got question 3. When it is of this format, x equals another function, then you have to first form an equation of the format fx equal to 0. So you can either take x on the right, or you bring what in the right on the left, whichever approach. And now we shall say x, we bring natural log. Remember that log e of x the same as ln x. Therefore, I can say x minus log of 8 minus x equal to 0. I bring log this way, then I let f of x be equal to x minus log of 8 minus x. Or you can say x minus ln 8 minus x as our fx, such that we say f of 1.2, which should be equal to 1.2 minus log of minus 1.2, such that when you put 1.2 in your calculator, automatically it will give negative 0.717. Let's now put 2 and see what we shall get. It is 2 minus ln or log base e of 8 minus 2. This one gives, put in your calculator, you'll be able to get 0.2082. Clearly, you realize that f of 1.2 gives a negative, f of 2 gives a positive, and conclude and say, since f of 1.2 is less 0, f of 2 greater than 0, then the root lies between 1.2 and 2. So those are the questions that you can have where they necessitate you to use sign change. Now I've got another question where there is a trigonometric equations or questions involving a trigonometric equation, as we said when we are looking at trapezium rule, like cosine of x, tan, sine, ensure that your calculator is in radians, because we are dealing with radian values, not degrees. And therefore, as our solution, we shall have x minus cos x plus 3 equal to 0 if I bring all the right part onto the left. Then you let fx be equal to x minus cos x plus 3, full stop, ignore 0. Then f of negative 4 will be negative 4 minus cos of negative 4 plus 3. Then f of negative 3 will be negative 3 minus cos of negative 3 plus 3. Use your calculators and you get the output clearly, such that if I put negative 4 in the calculator, the output would be negative 0.3464. If I put negative 3, I will get 0.990. And ensure that your calculator is in radian mode. If it is not in radian mode, you will get the output, but which is wrong. And therefore conclude and say that since f of negative 4 times f of negative 3 is less than 0, because you see f of negative is negative, f of negative 3 is a positive, then it means that the root lies between negative 4 and negative 3. Now I've got another case where they can say locate the range or ranges of roots of the equation. Here, when they say locate the range or ranges, it means you can have one or more than one range, and here we shall use a table of results and we shall be able to locate the ranges. Therefore, you let fx be equal to x cubed minus x minus 1. In this case, we don't use sign change directly. They all have been handling the upper examples, but we see the change of sign in a table by performing a dry run, a table of outcomes. So we shall have x, then fx. But equations of this nature, you can easily predict the range where the root or roots are expected to lie, especially if the coefficient of x is 1, and we shall be able to see that plus or minus k plus 1 will be able to give us the range, where k is the highest coefficient of terms. For instance, our equation, the coefficient of x cubed is 1, x is negative 1, and those are the terms. This is a constant term. So we shall have k magnitude. If the coefficient is negative, then we shall take that one as a positive, and we shall be able to get the range. But we should be able to know that the range sometimes is around 0. Values of the roots of equations are not so far from 0, so they all rotate around 0, but you can use this approach to get us the range. Therefore, for this very question, we can start our range of values from since k is 1, so we shall have to start from negative 2, then negative 1, then 0, then 1, then 2. This will be able to show whether we have range or ranges or values of the root. Now, when you put this equation in your calculator, it will be able to give you at x equal to negative 2, it gives negative 7. At x equal to negative 1, it gives negative 1. At x equal to 0, negative 1. At x equal to 1, negative 1. At x equal to 2, it gives positive 5. You will realize that if you go above 2 to 3 to 4 to 5 and so on. The values of f of x will keep on increasing. If you consider values of x more than less than -2, say -3, -4 and so on, we shall see the values of f of x decreasing and becoming bigger but smaller in negatives. Therefore, you will see that we are from negative, 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 then we have entered into the positive region of f of x. And clearly you will see that fx changes sign between 1 and 2. So the range or your root, the range for the root must be between 1 and 2. So we have got only one range where our root of the equation lies. It means because of x cubed, we expect 3 roots, meaning that this will be the only real root in this range, others will not be real. So we have one range where the root lies. We have another question that locate the root of the equation. Locate the root or roots. Locate the roots of the equation. So the question is talking about roots. So when they talk of roots, then you cannot use the above method in examples. The first examples looked at. You locate by doing a table, but to first say let fx be equal to x cubed minus 3x squared plus 1, such that we shall have x, then fx. Let us establish the range, the smallest and the largest value of x here. Now k is 3. You can see it here. The highest coefficient of the terms is 3. So we shall use our ranges of values from, because the coefficient of the highest is 1, so we shall add 3 or subtract 3 to get 4. So it will be k plus or minus k, then plus 1. This will be, it will help us to determine the range from the smallest to the highest in our table. So we shall begin from -4, -3, -2, -1, 0, 1, 2, 3. So we fill up this table, and we shall see that when we put -4 in our calculator, it automatically gives -111. When we put -3, it gives -53. If you put -2, it gives -19. Put -1, it gives -3. If you put 0, it gives +1. +1. If you put 1, it gives -1. If you put 2, it gives -3. And if you put 3, it gives 1. Then if you put now 4, it gives 17. Clearly you will see that when we go to values less than -4, the f of x will be smaller. If you put values of x more than 4, fx will be larger. Therefore, you will see that in the table we are from negative, 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 then we enter into positive. So there is a change of sign between -1 and 0. So that will give us the first range. The first range will be the root, the first root lies between 0 and 1. It is where there is a change. So it is between -1 and 0. Between -1 and 0. Negative 1 and 0, it is our first range where the root lies, because f of x is negative, from negative to positive. Then we also see that we are from positive now to negative. That will be the second range, which I have already written down. So it will be from positive into negative values of f of x, and that is between 0 and 1. Then you can see that still we are from negative, then into positive at this level of negative 3 and 1, and that means the third range would be between 2 and 3. So we shall have the third range between 2 and 3, since f of x changes sign between negative 2 and 3, because you see at 2, negative 3, at 3, 1. Therefore, there is the third range. So, locating of the equation of our roots means that you have 3 possible roots, which are in the first range, the second range, and the third range. So that's how we can handle questions of location. Now, they can ask a question that show that the equation x cubed minus 4x squared plus 4 has 1 negative root and 2 positive roots. The same approach. You let fx be equal to x cubed minus 4x squared plus 4, such that a table of results is drawn, x, f of x, and similarly our k is 4. As you can see, the biggest coefficient is 4, but the highest power of our coefficients, the highest power of x, its coefficient is 1. So we shall have the ranges starting from 4 plus 1, which is negative 5, up to positive 5. And therefore we shall begin from negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, then 5. Enclose your table. Put the equation in your calculator such that it gives you values, and we shall say that we shall see at negative 5 shall get negative 2, 2, 1. At negative 4 we shall get negative 124. At negative 3, negative 59. At negative 2, negative 20. Negative 1, negative 1. At 0 shall have 4. At 1 shall have 1. At x equal to 2, negative 4. At x equal to 3, negative 5. At x equal to 4 shall have 4. At x equal to 5 have 29. Similarly, you will see that the values of f of x are increasing as you go towards values away from 0, and decreasing as you go to values less than 0. And it means you can now check through and see that there is from negatives to positive at negative 1 and 0. Therefore, we can have a negative root in the range, which you can clearly see that between negative 1 and 0, f of x changes sign. So the negative root will be in the range negative 1 and 0. We shall have a negative root there. Then when you move ahead, you can see that now we have entered into a positive here, positive, but later on the sign changes, meaning that our root, which is the first positive root, lies between 1 and 2, where the function changes sign again from 1 to -4. And now we end into negative, then finally you see that the function still changes sign from -5 to +4 between 3 and 4. So another positive root lies between 3 and 4, because from 3 to 4 f of x changes sign. Therefore, these are the two ranges where you shall expect a positive root, then this is where you expect a negative root. Now, after looking at that, and if you have mastered, then you'll be able to answer questions like this question number 8, where they say that show that the equation has a root between 2 and 3. Hence, use linear interpolation, and you looked at linear interpolation as the method of estimating values which are not tabulated, or values which are not given in the table, on the assumption that the values you get will sufficiently behave linearly as the given table values, and that is linear interpolation. Therefore, if a question says show that the equation has a root between 2 and 3, then you can use such sign change method. You let fx be equal to x cubed minus 3x minus 12. Then f of 2 will be 2 cubed minus 3 times 2 minus 12. And this automatically give you -10 if you use your calculator properly. Then f of 3 will be 3 cubed minus 3 times 3 minus 12. And this automatically will give you 6. Clearly, you will see that f of 2 is less than 0, and f of 3 is greater than 0, and the root must lie between 2 and 3, as we looked at. Now, hence use linear interpolation once. It means we shall have to draw a table of outputs from 2, and we say the root lies between 2 and 3. Let us call it x0, then 3. We know that x equal to 2 gives our value of fx as -10. Then at 3, 6. But we know that roots of equations along the x-axis where fx is equal to 0. Fx should be equal to 0, and read the values along the x-axis where f of x is equal to 0. Therefore, if we're estimating, still we shall have the value of f of x at what we're estimating x0 to be equal to 0. Therefore, we shall use linear interpolation as usual. Say x0 minus 2 over 0 minus -10 can be equal to 3 minus 2 over 6 minus -10. If you compute, you will get x0 as 2.625, but remember our answer is supposed to be 2 decimal places, 2 dp's, and that is 2.63 dp's. If the question is give your answer to 2 decimal places, your work should be to more than 2, that is 3 or more, as we looked at under trapezium rule. So avoid premature rounding off when it comes to this work of estimation or approximations in numerical methods. So dear viewers, that's what we can say about sign search. So next we shall look at another method of how we can estimate roots of equations using graphical method. Wish you the best.